everybody. This is Jeff Jenness, and welcome to our second portion of the lecture on spatial data types. The last portion we discussed workspaces and geodatabases, and now in this section we're going to jump right into actual spatial data with actual graphics and interesting stuff. So we'll start with vector data. Okay, probably 90% of all the data you will ever want to analyze and work with in GIS will be one of two formats. It'll either be vector data or raster data. These are both really common data formats in GIS. They're both really useful. They're very different from each other, though. The ways of displaying and analyzing them are very different from each other. It's almost like two different fields of GIS. So we're going to start here with vector data. Vector data are precisely defined spatial objects, points, lines, and polygons. And by precise, I mean that they are they're measured. The coordinates are recorded to a very high precision. If you look at the coordinates that are recorded, they are precise practically to the atomic level. Obviously not accurate to that level, but they're extremely precise. They are defined by one or more points called vertices, or sometimes vertexes. Now, each vertex has coordinates, x and y, and sometimes z. Sometimes they even have one called M, stands for measure. You see this sometimes in linear features, where each vertex along the line will have an x, y, sometimes z, but it might have a value that says how far it is along that line. So it might be 50% of the way along or 70%. That's the M coordinate. It's not common, but it's out there. You see it a lot in street maps, or street data sets, where you're trying to figure out the XY coordinates of an address, and the address is calculated on the fly based on its measure value. Anyway, points are composed of a single vertex. Polylines, by the way, are the name of linear features. They're not called lines in the GIS world. They're called polylines. They're a set of linear features composed of a series of connected vertexes. And polygons are basically the same as polylines, except the last vertex is connected back to the first one, and it creates an inside and an outside. So, by the way, regarding this issue of polylines, polylines is one of those terminology things that you got to learn for GIS. And there's a lot of terminology is confusing. So when you're looking at a linear feature, remember it's called a polyline. There actually is such a thing as a line in ArcGIS, but a line is a single segment that connects two vertexes. And so a polyline is just multiple lines strung together. Anyway, when you talk about data sets, it's a polyline data set if it's a set of linear features. All right, so here's an example. Typically, these vector objects are not composed of true curves. They are connected from a bunch of vertexes all hooked together. So when you look at the image on the left here, it looks like this polygon has curves in it, but in reality, when you zoom in, you see it's just a bunch of vertexes with straight lines connecting them. Now, there are such things as multi-part vector objects. So here's an example of the state of Hawaii. This is the 7 main islands of the state of Hawaii. Well, the 7 island polygons, is that a single polygon, or is that 7 separate polygons? Could be either. It doesn't have to be one or the other. I just want you to understand that you can have separate disconnected pieces of a polygon or a polyline that are all recorded as the same object. So there's no rule against disconnected pieces recorded into a single object. The difference to you between the state of Hawaii, if it was multi-part or each one was separate, means that in ArcGIS, could you click on one of the islands and get information just on that single one? Or if you clicked on it, would all of them become selected and you get information on the entire batch? That's how it shows up for you. Okay. Now, there are some vector special cases, so almost all vector data are made up of some combination of points, polylines, and polygons, and that's what we're going to be working with. In this class, we're only going to be working with points, polylines, and polygon data sets. And they will be, as I showed you in the image earlier, they will be like this, where they're a bunch of vertexes strung together by lines. Now there are some cases where a vector object is composed of true curves. You see that in CAD, computer-aided design, like AutoCAD data a lot. And in this case, they can have circular arcs, they can have elliptical arcs, they can have these Bezier curves. Now, they're still vector data sets because they're still defined by a series of vertexes. But in this case, the vertex just has a little extra information telling it how to curve the edge. All right, so these data sets are out there, but we're not going to use them in this class. Okay, so there's 3 common vector data set types that you'll often run into. And by far the most common is this thing called a feature class. The second most common is probably a feature data set, and you will see a lot of triangular irregular networks. These are usually referred to as TINs. So let's look at a feature class, by far the most common example. Now these are simply a collection of points, lines, or polygons along with attribute data. Now the points, polylines, and polygons, these are called shape types. Any single feature class can only contain a single shape type. So if you have a feature class, it's going to be all points, it's going to be all polylines, all polygons. You're not going to mix them up. There's actually another feature type, shape type, that I'll show you in a second, but it's fairly uncommon and we're not going to work with it. Now, a feature class, it's a collection of points, lines, and polygons. The vector objects, the actual point, line, polygon, are called geometries or shapes. Then each geometry and shape is paired with a set of attribute data. This is what makes a feature. So a geometric object connected with a set of attribute data that describe that geometric object, these make a feature. Then you get a bunch of features together and it is a feature class. Now, feature classes can be stored in a variety of ways. It can be a shape file, which means it's a file-based data set. It'll be stored in a folder workspace, or you can store them in a geodatabase. In either case, they are still feature classes. So this means that a shapefile, whenever you see a shapefile, it is just a feature class. All right, so let's look at some examples. In this case, you're looking at 2 parts of the same feature class. On the left, you see the geometric objects. These are what show up in the map. And on the right, you see all the attributes that are connected with each geometric object. So each row in the table on the right is matched up with a single geometric object in the map on the left. You can have point feature classes. Each point is represented by just x and y coordinates. This means that the points have no size. You can symbolize them in a map based on some attribute value where you can make some dots larger than others, but the point itself has no size, so the points aren't large or small. They're just x and y. Polyline means you take a bunch of points, string them together, and you can symbolize them differently, but one thing about polylines is they have no width. They can be symbolized, they look wider, but the polyline itself has no width to it. And then you got your polygons. Take a bunch of vertexes, string them together, and make the last one connect back to the first, and you have a polygon. It has an inside and an outside. Now this is the other shape type that's much less common. It's a 3-dimensional shape type. It's called a multi-patch, and they're kind of cool. They're fun to play with and look at, but they're a little tougher to work with, and they're hard to create, and we're not going to use them in this class. So I just want to show you a picture, but this is as far as we'll go with them. Okay, so I've been talking about quick summary, two broad categories of data, vector and raster. We're talking about vector right now. There's three most common categories of vector data sets. Those are feature classes, feature data sets, and TINs. We've talked about feature class, so the next up is the feature data set. Feature data set is not an intuitive name. This is another issue of terminology in ArcGIS that is not intuitive. A feature data set, it sounds like a data set of features, doesn't it? But no, that's not what it is. A feature data set is a very specific type of data set. It is a set of several feature classes, possibly other data types, that are related in some way and they're stored as a single object. So, for example, maybe there's some phenomena out there that you are trying to describe and map and analyze, but it is too complex to be contained into a single feature class. Remember, a single feature class can only contain a single shape type, so it can only be points, polylines, or polygons. Suppose the thing you're looking at requires more than one of those. A sewer system in a city is an example. Sewer is composed of pipes, and it also requires a lot of point locations that might be pumping stations or whatever type of stations. And so the system itself requires both points and polylines. Well, we can put those into a single feature data set, and we can set up connections between them so they are related. And now we can describe these more complicated systems. Featured data sets are almost always stored in a geodatabase. There's a few exceptions. Things called coverages, SDC, Smart Data Compression data sets, and CAD data sets, they're not stored in geodatabases. But typically, featured data sets are in a feature data, in a geodatabase. A shapefile cannot fit into a featured data set because a shapefile is not stored in a geodatabase. So here's some examples of featured data sets. Looking at this thing called point data up on top. Point data is composed, it's a featured data set that contains three feature classes. You see the arc, the point, and the tick feature classes. On the bottom, we see a feature data set named for topology. It's just something I created for an analysis, doing topological analysis, so I named it that. It contains two feature classes, one called new features, one called transline. And then feature data sets can also contain other types of data, like that for topology thing on top. This is an analysis of the spatial relationship between those two feature classes, and it helps me identify areas that might be problematic, where one line doesn't touch another when it should. Now we're going to look at some examples of topology soon. Here's another featured data set example. I have a featured data set named F dataset for topology. It contains a polygon feature class of culverts, a point feature class of road signs, and a polyline feature class of transportation, plus this topologic data set that looks at spatial relationships between them all. All right, so that's feature data set. The third most common type of vector data set is a TIN, a triangulated irregular network. Now, this is a special type of vector data. It forms a three-dimensional surface that covers a landscape, and it's made of triangles, which is where you get the name triangulated irregular network. Now, unlike feature classes, TINs do not have any attribute data stored with them. They're purely a geometric thing out there. But as such, they provide several useful measures to calculate slope, aspect, and elevation on the fly at any point on the TIN surface. And I'll show you a picture that might help explain this in a second. They're really good at illustrating the shape of the land. All right, and they're also good for calculating surface area and volume. So here's a picture. I'm looking at the same TIN from a vertical perspective and also at an angle. This is a TIN representing the Grand Canyon. If you zoom in closer, you can see that it's entirely made of triangles. And every TIN this is the definition of a TIN. Now this means that you can click at any point on the landscape. ArcGIS will immediately determine which triangle you're clicking on, and it can easily determine where in that triangle you're clicking on. Since the triangle is a pretty simple geometric shape, it's defined from 3 points that are sitting in space, it can easily calculate the elevation, the slope, and the aspect based on those 3 points. So it's a pretty cool way of getting at that information, and it does it pretty easily. All right, so that is our discussion of vector data. Recall there are 3 main, most common categories of vector data sets. That's your feature class, your feature data set, and your TIN. And of these, feature class is by far the most common. Feature class is a set of features. Each feature is composed of a geometric object matched up with attribute data. And we're going to spend a lot of time with feature classes. In the lab, I have a TIN that you can look at and play with and see how it works. But other than that, we're not going to work anymore with TINs in this class. All right, thanks so much.